So let me give you the class key. So it's yorku.ca. Okay. And then the number is 8327. And then 6553. I will post this class key in the e-class after class. Okay. Okay.
Sir,
Yeah.
is this the WebAssign class key?
Yeah.
Okay.
Have you bought the right one? All of you?
Do we include the York UCA or just the numbers?
No, CA. yorku.ca. And then the number.
Okay, thank you.
Okay. All right. So I will post this in e-class afterwards. So now let's continue.
Sir,
Yes.
there's no WebAssign link on eClass. I've been trying to look for it. I'm very confused. Is it on the
It's
is it
in
on
the-
eClass somewhere?
It's in the bookstore. Okay.
The WebAssign?
But there's like no direct link to access it. We have to go from
Yeah.
Cengage.
No, you can actually go to the e-class. There is a link there to the bookstore. And you can purchase it. Okay. Go
Okay.
to class. There is a link to the York U bookstore. And then you can purchase it. I don't know how to purchase it, but they will tell you. Okay.
Okay, not the textbook. Okay.
It's well, I heard that it's the ebook that they have because students nowadays have the tendency to buy the ebook instead of the physical book. I don't know, but that's what they claim anyway. Okay.
Okay.
But I think there are some copies of the physical book also. So if you want to buy the physical book, buy the physical book. I personally like the physical book, but they are the same anyway. Okay.
Thank you, sir.
But nowadays, this new generation, they are brought up with all these electronic devices. That's why they prefer the ebook. And it's cheaper. They say that it's cheaper. 53% cheaper or something like that. So it's up to you. Okay. All right. So let's come back to vector value functions. So we have a function.
Sir, one more thing, if that's okay.
Sure, go ahead.
In terms of the practice, will you be uploading it? like maybe after class, or are we just expected to kind of make our own practice?
Uploading it. You mean the assignments or practice?
The practice.
Well, basically it's like this. Maybe we can talk about this after class, okay?
Okay, thank you.
Yeah. So I have a function. Which I denote by R of t, which is a vector, okay, depending on time t. And it's given by f of t, g of t, and h of t. If you want to see this in vector form, is given by f of t times the vector I plus g of t. This is more or less a review of the Wednesday lecture for the sake of those who were not admitted to my own Zoom anyway. Times j plus h of t times k, where t is a variable. In some
Sir, sorry to cut you off, but is this form the vector form you said?
this is the vector form.
Okay,
This is the point form.
that's the point form. Okay.
Okay. And t is time in an interval. Okay. All right. We actually did this on Wednesday. Okay. Now let me tell you what I, J, and K are. They are the unit vectors. In the X, Y, Z space. And I is the vector along the x-axis, the unit vector along the x-axis, and J is the unit vector along the y-axis, and K is the vector, unit vector along the z-axis. Okay. So this is the formula for the function, and f, g, and h are functions of time. Okay. All right. So for a fixed time, you have a point given by this, whose coordinates are given by f of t, g of t, and h of t. But you can think of this as a vector. Okay? You can think of this as a vector. And the point here is f of t, g of t, h of t. All right. And we have a lot to study about this vector valued function in chapter 13. Now, what is the graph of R of t? Now, to look at the graph, we need a three-dimensional space. So we have the x, y, z space. We have the interval I to look at, which we can think of as a clock, timing machine. So let's put it here. From A to B. This is my usual way of thinking about curves in spaces. So this is the interval I. And then you are going to let time evolve from A to B. And imagine a particle moving in three-dimensional space. Okay? And then as time evolves, the particle travels along a trajectory, a path. Let's say something like this. Okay? And this is the initial point corresponding to time A. And this is the terminal point corresponding to the time B. And the particle is traveling in this direction with increasing time. So this is the graph of R of t. Okay, it's not lying in the plane. It's actually lying in space. Think of the room as a space. You have a curve, right? All right. So when you fix a time t, and you are going to end up with a point on the trajectory. This is R of t. Okay. So the aim of chapter 13 is to look at space curves or curves in three-dimensional spaces. Okay. Well, on Wednesday, I also gave an example of a helix, but I am not going to do it now because I will pick it up later today. Okay. All right. So this is basically what I did on Wednesday. Well, I did the example also, but I will record that later. It was a mess on Wednesday. Okay. Actually, I should keep this score. Now, our first topic is to look at arc length. I don't know whether you have studied this in 1310. When I taught the course a couple of years ago, I did it. But for the past 2 years, I think the calculus courses 1300 and 1310 were completely changed. Right? Well, maybe not completely changed.
I think they changed the textbook for this year as well.
They change it, yeah. They change it to James Stewart calculus, and that's it. Not early transcendentals, okay? I don't think that's the correct way to do it. Calculus without sine or cosine or tangent doesn't make too much sense. But of course, later on, you pick it up. Okay. And there are more proofs. Okay. But how do you like it anyway? I used to teach 1300 and 1310 a lot. But how do you like the 1300 and 1310?
1300 is all proof based, and 1310 has a bit of computation and proof.
Mine was the opposite.
1310 certainly has to be more computational because
1310 is basically weak proofs, but then 1310 is more like strong proofs,
Yeah,
what do you mean strong proof?
like heavy proofs, depending on your professor that you have.
Exactly, because mine was really heavy proof.
1310 was all proofs for me too.
Yeah, it was really heavy proof 1310.
But do you have arc length? I don't think so.
No, I didn't learn arc length 1310.
We learned arc length with Mender Chow.
So it's not uniform. Okay. Well, for this one, there are some proofs, but they are not heavy. Okay. Now, we are going to look at arc length. And then we have this X, Y, Z space. And you remember, we have a space curve. Something like this. Okay? And let's call this curve capital C. Okay? And if you remember, we have a clock. Okay, the initial time is A and the final time is B. Our problem is to find the length of capital C. And people actually call this length the arc length. Okay. So of course, one way to do it is to straighten it and use a ruler. But this is not the way mathematicians do it. So we have to work with this curve, which is not a straight line. Okay. So how to do it? So we are going to look at the following thing. So let's T be a fixed time. And then corresponding to T, we have a point on the curve. Let's say is here. R of T. Okay. And we are going to subject to this time T a very, very small increment, an infinitesimal increment. This is the way I like to teach calculus. Okay. Not partitions. Okay. They use partitions to define integrals. Okay. So we let dt be an increment in t, and this dt is usually very small, infinitesimally small. So we have an increment in t. Now, this increment may be positive, may be negative, but let's take it to be positive. Okay. And we are going to magnify it a little bit because we want to put this in the picture. So let's say we have time t plus dt here. Okay. And corresponding to it, we are going to have R of t plus dt. Okay. So when you give t an increment, then the point will move a certain distance along the curve. Its new position is here. Okay. Now, to make the explanation a little bit easier to understand, let's look at a two-dimensional curve. Well, I mean a curve in a two-dimensional space. The idea is the same. So we look at the XY plane. And then we have a curve. Something like this. And this time the curve is actually lying in the plane itself. And then we have the point P. Let's call this point P. And this point Q. Okay. So we have the point P and we have the point Q. The reason for using a two-dimensional figure to illustrate the general situation will become clear in a minute.
Professor?
Yeah.
So when I enter the WebAssign, the course link and the product key, it says it's used, it's a redeemed somewhere else. Is it right?
And can we talk about this later?
I'm sorry?
Can we talk about this later? Okay. We can talk about this after class. Okay. All right. Now we are interested in the length PQ. Okay. But first of all, let's try to join Q to P. By a chord, a straight line. Okay. So the actual length PQ. Okay. Along the curve, which is the arc length. So we write it like this. Now, remembering that T is here. T plus BT is here. And BT is very, very small. Okay? So this tells us that this arc PQ is very similar or very close to the line segment PQ. Right? So let's magnify this a little bit. We have PQ here. Okay. So I am going to look at a triangle. A right angle triangle. So the magnified picture would then be something like this. So there is an increment in x. So this is the x. And there is an increment in y. And we call this dy. Right? We call this dy. So what is going to be the length of PQ? So this is equal to the square root of dx squared plus dy squared.
Sir,
Yes.
do you mind explaining the PQ is equivalent to PQ vector?
That's not a vector. That's this line segment. PQ is the line segment.
Oh, okay, from P to Q, that's the arc. Okay.
And then this curvilinear thing means the actual path from P to Q.
Oh, so you're saying that they are roughly equal.
They are roughly equal. Why
Okay.
are they roughly equal? They are roughly equal because Q is very close to P,
Okay.
right?
Yeah.
It's just like the Earth. The Earth is round. But when you are in a small spot, and that spot, which is actually curvilinear, will become flat.
Yeah.
So that's the whole idea.
Okay. Thank you.
So this length here, the length of the actual path is very close to this, or can, for most purposes, be taken to be like this. Okay? All right. So what should I take away? I can take away. So now let's come back to the vector value function. Which is R of t, and in 2 dimensions, this is just f of t and g of t. Okay? So this means what? This means that x is f of t. And y is g of t. Okay, so we have this. So what is the x? So the x is f prime t dt, all right? Because dx dt is f prime t, and I can multiply both sides by dt. So this is f prime t dt. And similarly, dy is g prime t dt. So we have dy which is g prime t dt.
Sir?
Yeah.
So from the x equals f at t and y equals g at t, so all you did was just get the derivative of both sides.
Yeah.
Okay, and then that's how you got the dx and dy equation. Okay.
That's, yeah. This is why I said that the change from the previous format to the current format is not ideal. Nowadays, they want proofs. well, which is good for some courses, but not so good for some other courses, like partial differential equations. Okay, but you can see it. dx dt is f prime t. dy dt is g prime t. Okay. All right. Now, from this, I can put this into this formula. So this tells us that the length from P to Q along the curve is equal to the following. So I replace dx by f prime t dt. So it's f prime t squared dt squared. These are called differentials. I don't know whether or not you were taught differentials or not. So this is dt squared plus g prime t squared. Times dt squared.
Hello, Prof.
Yeah.
I have a question. Why don't we just write the g prime t and dt together in one bracket and square it? Why did you separate it?
I just want to do it step by step.
Oh, okay, thank you.
Okay. That's more or less my habit. I don't want to skip steps. You are exactly right, because dt squared is a common factor. So I can pull this dt squared out. But when you pull it out, remembering that you are taking the square root, so we are going to end up with the following. So the length from P to Q along the curve is equal to the square root of f prime t squared plus g prime t squared. And then we have dt. Is this what you meant? If you pull out dt squared, you have to take the square root. That's why we have dt. The dt out. The dt is no longer under this square root. So what happens? So let's look at the picture again. Forgot what it looks like now. But it doesn't matter. Now, keep in mind that we have an infinitesimal arc length here. I just magnify it so that you could see the calculations. but in fact, it's very small. In fact, you can look at this small curve as one single point. Okay? As one particle. So corresponding to this time t, we have this infinitesimally small line segment. Or you can consider it as a point. Now, when you let t go from A to B, and you are actually adding all these little line segments together, right? And that's integration. Okay. Therefore, the arc length of the curve C is actually the integral from A to B of the square root of f prime t squared plus g prime t squared. And the integral is with respect to t. All right. So this is much better, much easier to understand than using partitions, upper sum, lower sum, Riemann sums, and so on. Now let's try to generalize these to 3 dimensions. So I have a generalization. So let's
Sir.
Yes.
Sorry, sir. Can you just explain quickly how the antiderivative of the length of P of Q with in the dimension of R2 is the integral of that for R3?
I don't have antiderivatives.
Pardon me?
I don't have antiderivatives.
No, why did you say that the arc length of C is the integral of PQ at R2?
Okay. Now we have calculated the length at the point T. Or a very, very small curve from T to T plus PQ.
Okay.
But for all practical purposes, you can think of it as a point. Because T dt is very small. So when you want to find the length of the entire curve, you have to add up all these little lengths. And
Mhm.
adding is integration.
Okay.
Okay, now let me turn this off first. Okay. Does it make sense?
Yeah.
Okay. Well, perhaps when you use additions, your teacher did not tell you that integration is summation. Infinitesimal summation. Okay. But that's actually much more intuitive
Yeah.
than using partitions. Now, we have a generalization to the X, Y, and Z space. So I am going to look at the following thing. So R of T is the function given by f of t, g of t, and h of t. Okay, where t is a point in the interval I. And this time we have a curve. In three-dimensional space. Okay, this is C. So the arc length is equal to the following. Is the integral from A to B as before. So A, B here. So is the integral from A to B of the square root of f of t squared plus g of t squared. No, prime, you have a derivative. And then you have the derivative of h. dt. Okay. So you have just one extra term, and that's it.
Okay, so sir, so you found out the equation of the arc length for the dimension being at R2, and then you just added the h at t because we're at R3 now.
Yeah, this is for R3.
Okay.
Okay. All right. Now let me do one example. Do I have enough time? I don't have enough time anyway. Okay, so I will stop here. because I want to do one example, the hearings. Now, you can ask me questions about the books.
So will you be setting assignment for today?
Not today, next week. I haven't done enough yet, anyway.
Hello, sir.
Yes,
So I think some of us have bought the textbook that the bookstore offered us. And
Mhm.
then when we tried using the code on it didn't work. It said it had already been redeemed.
Yeah.
So we have to rebuy it, or do we have
you
to
may have
contact
to
anyone?
rebuy it. But
Okay,
contact them, exchange it. You can exchange it if you bought the wrong book.
all right. I'll see if I
Um,
can.
I actually think I figured out what happened. On the school's bookstore, they were selling the red version of the book, and what our WebAssign has is the blue book. So when you put the code in for the red book, it's not registering in for our class. So it's saying that you're registering the wrong book, and it's not allowing you to go into the class. Is what's
That
happening.
I know, yeah, yeah.
Yeah.
That's exactly the point, yeah.
Yeah.
You have to buy the WebAssign corresponding to the book.
Yeah, no, but the issue is the York bookstore isn't selling the blue book that you want us to use. The one that the York bookstore is selling is only the red one. I literally just tried to go through
Well,
the,
that's what I said at the
Yeah.
beginning. They have the ebook for this course.
So then it would have to be straight through like Cengage or
Yeah.
whatever that website is.
So
you're
will you
best
put
off
up a
doing that,
link?
yeah.
Right there, yeah. Go to the website there and well, because I talked to them before classes began. And then he told me that the WebAssign and the ebook form one package.
So will you be making a direct link from the class site then to WebAssign?
No, you cannot. You have to buy it. Okay, you have to buy it.
I believe she
From the
means like when we
bookstore.
want to access our like assignments, will you post the assignment link on eClass so it's directly like from eClass
Wow.
we could go straight to WebAssign?
I
That's
will
kind of
assign the assignments in WebAssign. Okay. And then if you have bought the WebAssign and if you have access to it, then you can do the problems online. Do you understand me?
I have a question.
Mhm.
I have the calculus, Stuart Calculus 8th edition, only transcendentals already on my
Yeah.
hand. So
Yeah.
can I buy WebAssign only separately?
You have to ask them.
No, I asked the bookstore that
have to
question
both.
and they said no. It comes as a package with an ebook.
Yeah, so
With
it doesn't
the
matter if you
ebook,
have
yeah.
the book or
That's
not, you
right.
have to buy the WebAssign.
Wow.
Yeah, even if you have the textbook like I do, you still have to buy the ebook with WebAssign combined.
This is what happened. Because when you bought the whole book, you did not buy the WebAssign for the whole book. You only bought the WebAssign for the semester, for that particular semester. And that you cannot use again. You know what I mean? The book has 3 parts: 1300, 1310, and 2310.
Yeah, but Professor, your book is different from the 1310.
I know, I told you already, because they changed the curriculum.
Okay.
Yeah. My book is different from 1310, but it's the same as 1013, 1014, and 2015. And I am sure they are using the 8th edition also, early transcendental.
Hey, Professor.
Yeah.
So my access code didn't work. Now I have to exchange it. Can you tell me what book the access code to exchange to?
Well, there is a link there. There's
Yeah,
a
it doesn't
link
work.
on eClass.
Yes, I bought the access code. It doesn't work. It said I already registered it.
Well, then you should ask them. There is a link to a question page. Okay, ask them what to do. I know it's very confusing because there are too many calculus courses.
So you mean we have to buy multi-term access code? Not just one semester, but several semesters?
No, for this particular course, 2310, okay? They have available the ebook, and the ebook and the web assign is one
Bundle.
page.
Oh,
So professor, may I only buy one semester?
Yeah, you can buy only one semester. Yeah.
But it shows I only can buy the multi-term. I cannot
Yeah,
buy,
yeah,
yes,
when I try to search the course, there is only one option, multi-term access, not single term.
Yeah, you're gonna need to just do the full
you mean
term. It's
single
gonna
term.
just run out. And if you have a course next semester that uses WebAssign, then you can use it towards that. But other than that, it's basically just wasted time. That's kind of what they do.
But this is already the last of the sequence of calculus. This is the last. The
Right,
last.
so
part of-
we should be getting single term then, because we don't have anything else going forward. So why do we need multi-term?
No, you don't have to buy the multi-term.
But
Hey, so I
someone-
sent the single term in chat, so if you can check
But
in
that's
chat, I
in
sent them.
E-class, but that's in E-class.
Okay,
That's
good.
in E-class and is available as an ebook. All right? And it's much cheaper according to them. That's what they told me. Do you
Hello, Professor.
understand me now?
Our cover is the blue book, right? Just to clarify that.
Wow.
Yes, it is
I
blue.
cannot tell. I cannot tell the color because the copy I have is different from yours anyway. Well, the book that I am using is called Calculus Early Transcendentals. That's the book.
Just a question.
And the
Have you
book-
already started the WebAssign?
So you have started?
No, have you already started the class
Yeah.
problems in
but
WebAssign? Because I don't
haven't-
see any right now.
I have set up the WebAssign, and I
Okay.
give you the class code also. I will post the class key again, okay?
Sir, how will the WebAssign assignments work? Where like you give it like every Friday or something? Like how
Every
does it work?
Friday, yeah, every
Every-
Friday,
Every Friday, and when is it due?
1 week later.
1 week later? Okay.
Is there?
And
Okay, continue. Sorry.
and is like for the questions, is it like multiple choice? Like is there multiple tries for the answers? Like
Well, you can see it's basically something like multiple choice, basically.
I think he means like, is if you get it wrong once, is that it, or do you get like 3
No,
tries to get it
I
right?
give you an infinite number of attempts.
Oh, okay.
oh, okay.
Well, infinite means 100. That's the maximum.
All right.
According to the web assignment. Okay?
So do we lose points with each try?
No, you don't.
Okay, great.
You don't. Yeah, I have been using WebAssign for a long time, yeah, and people like it. Yeah.
Sir, so is that like the only assignments we're gonna have, just WebAssign and then like the midterms and stuff?
Yeah.
Okay, so just WebAssign assignments?
WebAssign assignments,
Okay.
and then 2 tests and 1 final.
Sir, I also have another question. So the link you have here where it says click here to access your ebook multivariable calculus 8,
Yeah.
say 52%. So like I just press
What
this
is
link and I buy the ebook and then it comes with the access code for the WebAssign?
Yeah.
That's all?
Yeah, that's all.
Okay, so I just click on that link and I buy it from there?
Yeah.
All right.
Sir, that's a different textbook than early transcendentals. That was the problem we had.
But you did not buy the WebAssign for the whole book in the past. That's the problem.
No, we did, and you can't. And when we register first, when we go to WebAssign, we register with your course code, right? And we register with your course code that gives us free access, 12 days. And then we have to buy and then you have to buy the access code. The access code link is different. It's a different textbook than the one in E-class. It's a different textbook in general. So that's why we're having this problem. So the links that we sent now are for links for the transcendental one.
The link is only for multivariable calculus.
Yes, and then the WebAssign is for transcendental calculus, and it won't work if you have either.
No, I think the WebAssign is only for the last part, the multivariable. That's what they told me, if I understand them properly.
I was able to get on WebAssign with their early transcendental code. So all you have to do is just put in the class key and then you put in your code that you bought
And I guess
and it works.
that could be okay if you have the multi-term WebAssign.
Mhm. Will the first WebAssign be posted today?
No, next Friday.
Next Friday? Okay, thank you.
Okay.
Dr. Wang?
Yeah,
Hi. So are we currently doing chapter 13?
we are in chapter 13. Yeah.
Okay. So from 13.1 to 13.3, though pretty much the whole chapter.
That's the whole chapter.
Okay. Thank you
It's
so
only
much.
for curves.
I'm sorry?
That's only for curves.
Okay. Thank you.
13.3.
Thank you.
Yeah, up to 13.3. Okay. No, this book issue is really a mess anyway. From the publisher to the books that we use, because people keep changing the books every year. That's the main problem. But if you have the other one, not the early transcendental, the contents are the same, but the WebAssign is different. Did you use WebAssign before in 1300 and 1310?
In 1300 I did, but the professor, he had just made a link right to WebAssign and we just clicked on it, enter the class code, and we were right there. So I never experienced this situation where we're not sure.
No, this link was actually set up by the bookstore.
Oh, okay.
Not by me. And that's why I talked to, I think he's the manager here. And I talked to the manager. He's very friendly. And I think if you want to exchange something, certainly he's willing to do it.
Okay, thank you, Professor.
Okay. Any further questions? Okay. So then see you next Monday. Well, hopefully the textbook issue would be solved by then.
So, sir, do we wait for you to like fix the textbook issue till we buy it?
You mean?
Cause like I'm a bit confused which textbook to get and like.
Why don't you ask them? They know much better than I do.
Okay.
Okay, there is a question page on the link.
Just go to the
Okay.
SendPage
I saw
website,
that.
go right off WebAssign and just buy it off there. You'll be able
What?
to get it easily from there. If you
Wait,
go,
what?
So go to the search up like webassign.com
webassign.com. Hold on. Yeah.
yeah. And then it should bring you up to a page that says something about enter class key. You enter whatever that long class key was and you click enroll. It should
No,
bring up
no,
the-
no. Each class key is different. This is for York U, not CA.
Yeah, that would be for our class, wouldn't it?
Hmm?
That would be for our class, wouldn't it?
That's
Your-
for our class, yeah.
Yeah, that's what I'm saying. So he would go to there, click in our yorku.ca, whatever number it is,
Yeah,
and it should bring up the calculus textbook for our instructor for 2310.
yeah, then that could work also, yeah.
Then continue from there, and then it should bring up a page about which textbook, complete payment, proceed with temporary access. Instead of just proceeding with temporary access, just click buy now, and then it'll bring you to a page that you can actually like pay for the full multi-term textbook.
Okay, so it comes with the ebook and it comes with the WebAssign?
Yes, so basically, once you go into WebAssign the next time after you purchase it, it'll show your class, you click the class, and it'll show all the assignments listed for the class, as well as the material. So there's textbooks and any extra information that you need will be.
Okay.
I don't
Alright,
think
thank you.
we're able to do the same.
I think the textbook store put this up because they want to do some business, and that's it. Okay. And it's so complicated. But now you have the class key, so maybe that's.
Sir, so just to clarify, the class key is 83276553.
Let me see.
Yeah, and then you click
83276553, yeah. And
Okay,
then
so I do yorku.ca and then the class key?
And then the numbers. The whole
Okay.
thing constitutes the class key,
Okay,
okay?
yeah.
Okay, good. But actually, if you buy it from the publisher, maybe it's cheaper also. I don't know. And
Have a good day, Professor.
okay, you too.